All right, today's lesson is probability. What's your objective, class? Get ready?
Probability.
Probability. Today you're going to learn everything about probability, chance, odds. We're also going to do sample spaces, tree diagrams, and some experimental probability. So we're going to go fast. There's a lot of content here. Probability is the likelihood an event will occur. Probability always happens between 0 and 1. In other words, the fraction will always happen between those numbers. If the probability is 1/2, that means it's equally likely to occur as it is to not occur. A probability of 0 means it won't occur. A probability of 1 means it's certain to happen. So the probability of any event happening is the number of favorable outcomes divided by the number of possible outcomes. We're going to practice reading that. What is probability, class? Get ready?
Number of favorable outcomes
divided by number of possible outcomes. So let's do a probability on a spinner. What's the probability of it landing on A? Well, there's only one A on the spinner, so there's one favorable outcome. Out of 1, 2, 3, 4 possible outcomes, the probability is 1/4. The probability of landing on A or B, well, there's 2 desirable outcomes out of a total of 4 possible outcomes. So I reduce my fraction in probability. Okay, so in probability, make sure to reduce. What do we need to make sure? Get ready?
Reduce.
Reduce. So we reduce it to 1/2. So look, it's half the circle. That makes sense. There's a half a chance of landing on this half. What about sector A, B, C, or D? Well, 1, 2, 3, there's 4 desired results out of a possible 4 results. So the probability is 1. Or I could say, I have a 100% chance of landing on A, B, C, or D. The probability of landing on E is 0. It's not there. Okay, so let's talk about chance. You hear the weatherman say the chance of rain is 60%. Well, that's a good way to remember that chance is expressed as a percentage. How do we express chance? Get ready?
Percentage.
A percentage. So if they said, what is the chance, take your probability and convert it to a percentage. Now, odds is a little bit different. You've heard of betting or racing or sports. Sometimes they say the odds are 2 to 1. Well, what does that mean? The odds are the favorable outcomes compared to the unfavorable outcomes. So we're going to say favorable to unfavorable. What are the odds? Get ready?
Favorable to unfavorable.
Good. I like that some of you are writing that down. I think everyone should write that down. The odds are favorable, unfavorable. As soon as you're looking back at me, I'll know you're ready. That's a really good one to have in your notes. Okay, Kaylee's ready, Samantha's ready, Audrey's ready. Thank you. All right, so let's practice an odds problem. So what are the odds that the spinner will land on A? Well, there's one desired result, or one favorable, let's use the right terminology. There's one favorable outcome to how many unfavorable? Well, B is unfavorable, C is unfavorable, and D is unfavorable. So I put a 3 here, not a 4. In probability, we would have put a 4 here. But in odds, you put how many you don't want. The unfavorable. So favorable to unfavorable. What are the odds? Get ready?
Favorable to unfavorable.
Good. Favorable to unfavorable. Very good. All right, let's talk sample spaces. Sample space is a collection of all of the possible results. So if I had a coin toss, and my experiment was to find out if it's heads or tails, my sample space would be all the possible outcomes when I flip a coin. Well, the possible outcomes are brace, heads, tails, and brace. So it's just a list, but we put it in a set notation. We put it in braces. My spinner sample space looks like this. Rolling a dice sample space looks like this. Those are all of the possible outcomes, so we call it a sample space. What is it called? Get ready?
Sample space.
Sample space. So we're going to talk about the coin drawing. If a coin is tossed twice, what are the possible outcomes? All right, so let's do a first toss and a second toss. We're going to make what they call a tree diagram. Some of you will go, oh yeah, I've seen this before. So the first toss, we might get a heads, right? But we also might get a tails. Well, let's go with the first one. We got a heads, then I toss it again. I might get a heads, I might get a tails. Well, let's say that first toss I got a tails that time. Then I toss it again. I might get a heads, I might get a tails. This diagram shows a visualization of all the possible outcomes we could get. So let's show you how to do the sample space. We'll go heads, and heads is one possibility. Heads, then tails is another possibility. Tails, then heads. Tails, then tails. Some of my students last year got to the end of the school year and they said, Mrs. Boone, I have no idea how you went from here to here. So I want to make sure everyone's really clear. If you're like an ant and you're crawling on the tree branch, you have to crawl on every branch to find your home. So you have to go through T, then H, and T, then T, H, then T, and H, and H. And so you just make a listing of those. Our sample space in set notation is H, H, comma, heads, tails, comma, tails, heads, comma, tails, tails, end your brace. Now's a really good time to say, Mrs. Boone, I don't get it. Is there anyone not sure? Okay, which part? Is it on how I did these or how I got to here?
It's just like,
This
I don't
part?
know.
Probably this part, huh?
Yeah.
Yeah? Okay, you're probably not the only one. You're just the only one that had enough courage to say, I don't get it. So you understand that there's only two possibilities, right? Heads and tails. And the reason why I split them out is because I know I'm going to toss again, so I have to get a little room. After I toss that heads, let's say we'll do a little experiment. How about that? After I toss my heads, which I can't seem to toss it, okay, it landed on tails. So I'm now on this one. Okay? So now I toss it again. Tails. I went to this one. But couldn't I have easily landed on heads that second time? See how this is the first time, second time, or it could have been first time, second time? Does that make sense? Okay. Lexi?
Does the tree only work with two? Like,
Oh, no. We're going to do another one with three. Okay? We're going to do another one with a spinner, and then we'll do a free one. So let's talk about another way to do a sample space or a diagram to help us find a sample space, and that's with the spinner. We're going to spin the spinner twice. My first spin, I only have the possibilities A, B, C, D, but if I spin it again, I'm going to have another A, B, C, D. So here's a way to visualize that. All of a sudden, some of you are going, oh, I've seen this before. Okay? We're going to go first spin is down here. We'll go the second spin is up here. So on my first spin, I get an A. But then when I spin it again, I could get an A, or I could get a B the second time, or I could get a C the second time, or a D the second time. Is that making sense? Give me a nod if that makes sense. Okay, good. You're going to help me find the next one. So B is the first spin. What's my next letter? Get ready?
A.
A. What goes here? Ready?
B.
B, B. What's next? Ready?
C.
Let's be consistent. Let's keep these first. All right, so B, C. Next?
B.
Good. Next?
CA.
Very good. Next?
CB.
Next?
CC.
Next?
CD.
Next?
DA.
Excellent. Next?
DB.
Next?
DC.
Next?
DCD.
D?
D.
D. Okay, very good. This is, we haven't found our sample space yet. Well, this helps us write our sample space in set notation, but these are all of the possible outcomes, right? So the question says, find the probability of getting A at least once. So it could be one or more times. So where is that? Well, A happened at least once here, at least once here, at least once, at least once, at least once, not at all, no, yes, no, 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 yes, no, no, no. How many A's happened? 1, 2, 3, 4, 5, 6, 7. Out of how many total trials did we do? We have a 4 by 4, so there are 16. So our probability is 7 over 16. Number 2, find the probability of not getting A. Well, these were the A's, so these are the not A's. 1, 2, 3, 4, 5, 6, 7, 8, 9. Out of a total of 16. Whenever you find the probability of not something, that's called the complement. What is that called? Get ready?
Complement.
Complement. Another way to find the complement, if you don't want to count, you take the probability and subtract it from 1. Wouldn't that give you 9/16? Check it. Okay, there's your compliment. All right, someone asked, I think Lexi asked, well, what if there's 3 tosses? We're gonna do this one. This is gonna come up a few more times this year, at least 3 more times. This will probably be the only time I do all 3 on the board because it takes a little bit of writing and a little bit of room. First toss, heads, tails. Second toss, heads, tails, heads, tails. Third toss, heads, tails, heads, tails, heads, tails, heads, tails. Give me a nod if you're okay. Makes sense. Okay, very good. Outcomes. So now is where we go down. We're an ant and we have to crawl on every branch. And I'm going to call on students to help me. I'll do the first couple. H, H, H. Next one, I'd go H, H, T. What's my next one? All right. Connor.
HTH.
Very good. Lexi. So we did this one, and this one.
Oh, did you HTT?
Yes, HTT. Next, Rachel.
THH.
Perfect. Hannah. See, we've done this one and this one. Yes, THT. How about Bo?
Tails, tails, heads.
Tails, tails, heads. And Gage. I'm going to come back to you because I know you can do this. I just need another boy. Colin. T, T, T. All right, look at this. 1, 2, 3, 4, 5, 6, 7, 8. I have 8 possible outcomes. Right now I could ask you all kinds of questions. Like, how many times did we have tails twice? Oh, okay. You can say, oh, there's 3 8s. How many times did I have heads at least once? Oh, gee. Heads happen like every time except that time. So I could ask you all kinds of questions, so be ready for that in your practice set. Our last part of our lesson is to talk theory or experimentation. So probability, the theoretic part of probability is what mathematicians say could happen. So if I said we're going to flip that coin, which I lost, here it is. The theory says the chances of landing on a head is half a chance, right? 1/2. Or 50% chance. Landing on a tails is 1/2. That's what the math theory says. Well, what if I flipped it, which I think we lost it under Ethan's chair. Oh, there it is, Michelle. What if I flipped it, and let's flip it a couple times. Okay, heads. So, wait a minute. I have a 100% chance of landing on heads now. Well, I only did 1 trial. Maybe I better do some more trials. So, it's tails. I've got 1 heads out of 2 trials. That's 50%. That matches the theory. Heads again. So now I've got 2 heads and 1 tails. Heads again. 3 heads, 1 tails. Okay? So 3 out of 4 makes it 75% probable that I should land on heads. So all the math theory is wrong. So my experiment said it's 75% of the time. What can I do to make sure that my experiment draws closer to the theory? Jasmine.
Keep going until it's set.
Keep going. That is a RISE test question. At the end of the year, your standardized test will say, how can we make our experiment match more closely to the math theory? Do more trials. Conduct more. Maybe 100. Maybe 1,000, it'll have possible. Should I do 2 experiments or should I do 100 or 1,000? Which one is most likely to make your experiment match your theory? Do the most trials you can do. Okay. They do this in sports. They look at the free throw shooter that says 80 out of 100. Every time he shoots, they've counted, he made 80 out of 100. So does he have 80% chance of making his next shot? Yeah. So I could say 4 out of 5. Shots he would make. So if he shot 10 shots, I would guess he should make 8 of them, because I'm going to use his probability to help me find out what his chances are for the next shot. Baseball players do the same thing. So they have batting averages. They make sure the best batting average hitter will be your third or fourth batter to clean up everybody on base. All right, we're gonna go to our practice hit, page 214. Take a 20-second stand-up break. I know it's kind of warm in here, and that was kind of a long lesson.